Far more people signed up for the Rust meeting than there are.
Oh, yeah.
Far more people in the Rust meeting than are signed up for it.
Oh, really? We do have more people signed up for this, right?
No, it's equal. Of course, maybe some of the people who went to the Rust meeting signed up for the Northwest Sea.
Oh, yeah.
Not paying attention, not
Right.
looking closely at the sheet.
Oh, that could be. And we frequently get people that come in here when the meeting starts, but they start out in the Rust meeting for a little bit, so. We'll see. If nothing else, you and I will just have a chat about, static analysis. It's actually this was a filler presentation, so it might be a little short too. We'll see what we get.
There are a few regulars who seem to make a disproportionate number of presentations.
Mm-hmm.
You do, Daniel does some.
Yep.
You get some guests from outside.
Yep, and Peter's usually here, so. Although he usually goes over to the Rust meeting. I didn't see him, so I'm not.
I didn't see him at the Rust. I expected him to be here, but I didn't. Standing in back, I couldn't make him out.
Yeah, and I did the same thing. I was chatting with him today because I'll announce when we start the recording, but we're losing the reactor room, so. Yep, we need a new home and we're gonna move online for short term, but.
When do we lose?
July meeting will be our last.
Will be the last, okay.
At least for a little while. So nothing's constant but change.
Well, last year we did the pizza.
Yeah, we did that in September. Yeah, and I'll make a note on this too. I've actually got the September meeting open. And I was thinking about doing a pizza thing here. But that's not going to work, obviously. If we're pure virtual, pizza doesn't work. I'd still like to find a presentation for that. It's too late to book the shelter and stuff like we did last year. And that whole thing was actually super spendy.
Okay.
By the time you get the shelter and the event insurance and everything else.
Event insurance. Okay.
Yeah, you got to. If you're going to run an event, you really need that. Otherwise, people who shouldn't be can get held liable for somebody tripping over a twig or something. We'll see how it plays out. Oh, here are a couple more people coming in. Probably anytime the door opens now, it's us because they've been running for ages. Hey, it's Dan. How you doing?
Not bad stuff.
Reasonably well. Almost sane, but
Takes one in.
Yeah. Hey, well, I got you real quick. Nothing needed immediately for the CPPCon poster stuff, right?
Not yet.
Okay.
It'll close. I think the submission period closes end of July.
Okay.
And we'll have announcements early August.
Okay, that'll work. Turns out I'm not going to be able to make CPPCon this year either. I've got an overlapping event already. So.
Oh, really? I gotta get you back there.
Yeah.
Good times. What do you have going on?
A friend of mine scheduled a camping trip for me.
Oh.
It's somebody I've known since like junior high. If anybody's watching on the tape, you probably know who that is because I mentioned it before. He just called me up one day because we used to camp all the time. Okay. And he called me up one day and it's like, yeah, I booked you a campsite. We're right next to you. Here's the date. See you then.
Wow.
How could I refuse?
I'll admit, I know pretty much nothing about static analysis.
Oh, really?
It's something I hear about all the time, and I figure I should probably learn something about it.
Okay, I'll spend, given that, I'll spend a little more time going into just exactly what it is. I give a definition, but I kind of made the assumption everybody knew what it was, but I'll talk about it a little more.
Stuff like static analysis and linting.
It's basically linting. It's fancy.
But that I don't know. I mean, I just, when I worked in the field, it's just something we didn't, for whatever reason. I don't know. Maybe it happened, but I just wasn't part of it.
Yeah, it's something that's actually
And then,
fairly, it's not common to see in some, especially in some industries. In aerospace, it is common.
Yeah.
And that's kind of why I'm doing the talk is it's, you know, the tools you use in aerospace can be pretty darn spendy, right? Like $25,000 a repo a year for the tool, right?
oh, wow.
Yeah.
That's probably why we didn't.
And that's, yeah.
That one company I worked for. 'Cause they-
Right. Yeah, the commercial tools are spendy. And yeah, we'll give folks about another 5 minutes here to pop in. But yeah, if I see some more, nope, those sneakers aren't heading this way. Oh, wait, yes, they are. No, they're not. I can't tell. This is what happens when you have windows that are like, you know, half tinted.
Oh, you saw the sneaker.
All I see is,
Well, the whole concept is to have the window so you don't have a solid wall and then you block it over.
right,
Which is like, doesn't this kind of defeat
Yeah.
the point of the window?
yep.
Other than like you can peek underneath and see whether there's somebody in there or not. Yeah.
Yeah, we'll give people a couple more minutes here and then get going. I was saying before that, so anyway, that's actually kind of where this talk came from was, you know, using these tools in, you know, some of the more regulated environments and so forth. And there are definite benefit, but, you know, you pay a lot for some of them. The free ones out there are actually really good. And you know, it's one of the things you get used to if you're working with Rust a fair amount is it has they call it Flippy.
Rust.
Yeah, with the Rust language, it has a static analyzer that comes with it. But, you know, it's not as common in the C++ world, and I think it should be. So that's why I did this talk.
Yeah. Another thing interesting to learn more about are optimization tools.
Yes.
I know here he also wrote a book for O'Reilly. Came out just pre-pandemic. It's called Optimize C++. It's a really good book, but you know, I'd like to know, okay, well, what tools can we use? How do we use that sort of thing? So
Yeah. Yep. I'm getting the impression this is all we're going to get, so I'm going to dive into it real quick, and maybe we'll do it a little more as since there's only 3 of us, a little more discussion oriented.
we used to pack them in. We used to have like 20, 30 people.
Oh, I know. Well, and it's summer too, and we always get a little wimpy in the summer, so.
Part of it's the pizza, man. We got to bring back the pizza.
It's getting recruiters to sponsor that too.
We got silent.
Yeah. Okay, anyway, folks, we'll get started here real quick. We've only got a few people tonight, so this is going to be mostly, we got another one. Cool, welcome, hi. Okay, so we're growing. All right, we'll take what you get. All right, welcome to the Northwest C++ Users Group for June. I'd like to thank Microsoft for sponsoring our Reactor meeting room and our Microsoft Teams support. Please recognize the code of conduct, pretty straightforward, be nice to everybody. Do have a few announcements. In July, we're going to be doing a joint meeting with the Rust user group. That will be here. It's going to be a little bit of a sad meeting as well. July is also the last meeting we will be in the Reactor room for a while, at least. We are looking for a new venue. In the short term, we will go back to online only with Teams. And then as soon as we can find a new landing spot, we'll do that. It's also possible the Reactor may pop back at some point. If you happen to know of a venue like a company willing to sponsor folks coming in and just doing a small meeting. Let us know. I've also, or at least let me know. I've also been looking in the past, before we got the reactor room, we had the same problem. It's one of the things you run into running a users group is where to put people. I did also look at the various library community rooms around King County, and that's a possibility as well.
What happened with Microsoft?
Budget cuts. Yeah, it's reorgs and budget cuts things. So it's we'll see where it goes. I'm in I've been talking to the reactor room folks, and they don't know a whole ton yet. It's still up in the air, so it's could get reversed at the last minute, could come back in 6 months, could come back in a year. We don't know. So the key is we will be changing things up a little bit, and yeah, so we will be changing things up a little bit, at least for the next couple of months. And as soon as I know more, I will let you know. If anybody happens to know of a spot where we can meet, please let me know. The Rust group meets, some folks are aware of that one as well. Basically, there's 4 groups that tend to meet here, although I only noticed 2 tonight. Everybody's going to have the same problem. So August meeting will be lightning rounds. Plan for that to be online. I've got 1 lightning round so far. If anybody has a quick little talk, feel free. If you have a longer talk, the September meeting is still open. So depending on how everything plays out, I'll figure out what to do with September. It's also CPP Con, and historically we've skipped for CPP Con. Don't know.
Our meeting would be what, the week after?
Nope, it's dead on top.
Oh, really?
I think it's dead on top. I'll double check that. It usually, just for, the way the world works, it usually lands that way. There's 52 weeks in a year, and they just land that way. Okay, after the meeting, some of us get together at the local Red Robin to talk about programming and other stuff. It's on 148th and 24th. Anybody welcome to join? And get on to our feature presentation. Please keep questions short and focused so everyone gets some time. And don't interrupt the speaker or other members when speaking. The meeting or the presentation tonight is rather short. It's kind of another filler one because it turns out we more chaos with people moving around in different roles is catching up with us in all kinds of different ways right now. So you get me tonight. I'm going to talk about I'm going to talk and hopefully I'll make sense. Free C++ static analysis tools. Okay, so first thing is, what is static analysis, right? So this is basically from Wikipedia. It's an analysis performed of computer programs performed without executing them. In contrast with dynamic program analysis, which is the program is running during the analysis. If you go down a little deeper on this, in a more practical sense, essentially most static tools are pattern matchers. So there's a large rule base of patterns that you should not use. And the analysis tool can recognize those, and they say, hey, don't do this. While this sounds fairly simple, it's actually really, really quite helpful. If anybody's read the C++ core guidelines, you'll notice they were all written with the idea of somebody along the lines coming and building a static analyzer behind them. There may be one that exists. I'm not particularly aware of one at the moment that was written directly for that. I didn't find one when I looked for this. But both free open source and proprietary tools exist. I've used both of them in the past. The proprietary tools can be quite expensive. One of them, and I won't say which one, is, excuse me, $25,000 a year per repo. And that one we were using in an aerospace setting. If you have to have MISRA compliance, for instance, for automotive, that's also another place where you see these. A lot of the formal compliance standards are enforced by static analysis. Not in all cases, but you see it there more often. The cost of a proprietary tool is actually what prevents a lot more people from using them. I don't know about you, but I don't have $25,000 a year sitting around for even my couple of private repos, right? So let's talk about some free ones. It turns out the free ones are almost as good and generally good enough to get like 80–90% of the cases. Especially in cases where you don't have a formal compliance standard like MISRA that you're trying to go after. So here's a list of some free static analysis tools. The first one's the Clang Static Analyzer. That's part of the Clang tool chain. I've used that one quite a bit. Next one is CPP check. That's and basically these are I'm just listing them off. We're going to go through each one of these in a little more detail. So CPP Lint, OC Lint, and SonarQube Community Edition. There are other options out there. These appeared to be, at least when I did the search, the most common and the most well-developed.
Yeah. Are there any that are linked with Visual C++? Or does it matter what you're?
So for Visual C++, Clang Static Analyzer gets pulled in.
Okay.
I have not used it exactly that way, but I'm pretty sure I've seen the hooks for that. And if not, it's pretty straightforward to integrate into, the Visual Studio tool chain.
Okay.
Because it just happens to be that flexible. Okay, so let's talk about Clang Static Analyzer. So here's the website. We can go to the website if you folks want to take a look at it, but it'll be in the slides. The type and depth of analysis. So I'm going to kind of just grade each of these as we go through in kind of a standard manner. The depth of analysis is excellent. I've used Clang Static Analyzer. Well, one of the cases where I was not allowed to spend $25,000 a year on my repo, Clang was my first choice, and I went and grabbed it. And it works just fine. The analysis is excellent. Configurability is excellent. It integrates with various IDEs, Visual Studio, VS Code. I believe Sublime Text also has one, an integration plugin for it. The customization and extensibility. So how easy is it to add your own rules to the analyzer, right? That's something you do in a bigger group. It's common to do that so that you can enforce your own coding standards or your own coding paradigms with the team. Clang is excellent for this. It's part of the LLVM tool chain. And then, as everybody knows, that's kind of a toolbox, right? So it's easy to build on and work with. Performance is fast. And I would not say, so I'm going to talk about performance just a smidge here as we get into that. The performance of the tool is fast. That does not mean it runs in a small amount of time, right? So one of the drawbacks of doing static analysis, we'll talk about this later, is it does take some extra time, right? Your build takes longer, and I've actually seen static analysis. It depends on your code base. It can take as long as 2 to 3 times your compile time because it's doing a lot more work. But you don't have to run it all the time, right? We'll talk about that in a minute. The license is Apache 2.0 via LLVM. And as I've mentioned already a half a bazillion times, it's part of and integrated with the Clang and LLVM toolchain. Next one to talk about is CPP check. So this was a new one to me. It's open source. There's a couple of them up there. There is a premium or proprietary version of this one as well. So this one's a little bit of the gateway, a little bit of a gateway drug. And get them hooked and then bring them in. So the only one we're going to talk about tonight is the free version of this. It's the one I evaluated. I did not look as far into the premium version, but the premium version does support MISTRA and CERT coding standards. So if that's something you need to do, this is you could start with this, show its value, move on. Depth of analysis is excellent. There's a list on this one of all the checks that it does. We can go look at that in a little bit if folks want to. Integration is also excellent. There's plugins for the common IDEs. You'll note in yellow, one of the things that I found very interesting about this particular tool and unique to this particular tool is it has its own parser and supports non-standard syntax. So folks may know in the past, I've done a couple of talks, or at least one talk, there's actually another one coming, hint, hint, on CUDA. And I also do a fair amount of embedded programming. Both of those have non-standard C and C++ syntax in them. This particular tool will deal with it, where other tools may go syntax error, blah. Right? Customization and extensibility is excellent. It supports Python-based add-on scripts. Again, performance is fast. The license is GPL 3.0. And I also mentioned the premium version supports MISTRA and CERT. Next one on the list is CPP Lint. It's limited. This one appears to be more style-focused for its analysis. So it's looking more at stylistic issues, not things like use after free or, you forgot to free this memory, that type of stuff. It is CLI only. The customization is limited. Performance, I didn't actually run this one, but it's likely pretty slow. It's written in Python, which I thought was interesting. The license is a Google license. And this one does not appear to have a website beyond the GitHub repository. It was originally developed by Google and no longer maintained. Although when I was hunting around, I still got the impression this is, fairly commonly used. So I included it. OC Lint. This is a little bit of a build upon. It builds on the Clang static analyzer. Integration and usability, it's rated medium. It's CLI only, but it can integrate with the Clang static analyzer. I have used Clang static analyzer and I'm not sure what more it needed, but there's this one. Customization and extensibility is excellent. Its performance is slow, as reported. It's a modified BSD3, and it's Linux and Mac only, OS X only. So it's interesting, this one does not support Windows.
Sorry, dumb question, but CLI only, I thought that was like .NET and stuff like that.
No, so it's command line only.
Oh.
Right, so some of them support.
That's a different.
Yeah. Most of the time, that's not a big deal.
Yeah.
You can, but some of them have tools that will integrate into your IDE and show you things, real time and things like that, and various. But this one's like just put it in the CLI, and for all intents and purposes, a CLI only interface is generally good enough, right? Okay, SonarQube Community Edition. I included this one because it's kind of another gateway drug. Its depth of analysis is limited. You can only have 50,000 lines of code per project before you have to go up to the paid version. But if you're looking for something for a paid version, okay. The other thing that I thought was interesting with this one, it's a cloud-based solution. So all of the other tools run locally. This one, in some way or another, uploads your code into a cloud and does the analysis in the cloud. For some people, that might be great. That might be why it's so fast. And for some people, that's going to be a showstopper, right? If you're doing proprietary or code that comes under ITAR compliance, for instance, uploading to the cloud is simply a no-no. Okay, so when comparing things, I like to put them all into one of these little summary tables. So here's the table for this one. Down the left-hand side is the tool, and then each of the metrics that I was looking at. So they're all in a table. Once you get one of these tables, the next thing you generally want to do is come up with a selection criteria, right? So this is going to say, you know, for your project, what are the things that are important to me? So in my particular case, you know, I want deep analysis. I want a really good analysis. I'm willing to pay for the time to do that, right? As I was saying, a CLI interface is good enough for me. I typically put these in batch or make files or whatever. So that's good. Any open source license is fine. Performance fast, although keep in mind, fast performance does not mean, you know, small latency necessarily, right? It's relative. And the other one, as I mentioned, I do a lot of CUDA, or I tend to do some CUDA stuff, and I do a lot of embedded stuff. So that the feature of CPP check that allows you to have non-standard code, that really stood out to me. So it's like, okay, I've done Clang before. So for this talk, I decided I'm going to go down the road of CPP check and give it a try. So the rest of this talk is essentially picking CPP check, installing it, giving it a test drive on a simple program. For that simple program, do folks remember simple CUDA that I did in my CUDA talk? If not, that's totally okay. It was just some simple CUDA code that we can go look at, you know, live if we want to, and you know, gave a good target for doing this. So that's what we're going to use as the analysis target. Okay, installing CPP check. This is really, really simple on Debian-based Linux. The other thing I do, I'm getting away from this a little bit, but I tend to want all of my tools to run on at least Linux and Windows these days. I used to have the requirement of Windows. Apologies, folks. It's going to be one of those nights. Windows, Mac, and Linux. But mostly what I'm doing now is Windows and Linux stuff. So that's good enough. This will run on both. If you happen to be on Linux, sudo apt install CPP check, right? And that will give you just the default version, which is 2.17. On the top version of Linux that I'm using. There is a later version. I think it's 2.15 or 2.14, something like that. For this talk, I didn't update to the latest one. I have done it. It's pretty simple. You just go grab it, install it, and off you go. It also builds, if you're going to grab it from source, it also builds just fine. I've done that. So running it. As I mentioned, we're going to use the simple CUDA code base from my prior talk, just because it's a simple C++ code base. It also incorporates some CUDA code, which is something I'm interested in, and lets us look at the, you know, how this unique feature of dealing with non-standard syntax in your code works. If you run CPP check without any parameters, it provides help. There's also a manual. This is a small clip of what it provides. There's a ton of options on this thing. It's very configurable via the command line. So let's run it. To check a folder, you simply say CPP check and give it the path. So I did a little CD into simple CUDA and said CPP check dot. And you notice it says checking GPU.cpp. And if you look at the files I have here, all the CUDA stuff ends in a .cu, right? That's CUDA's notation for basically CUDA code, right? which is CPP code and passed to the NVCC compiler. Well, okay, that's not quite what I had in mind. So if we add a few more command lines, and it turns out everything, to get this to work for this, everything needs to be added. So you say CPP check -- language C++. You can specify the standard. C++ 20 is what I was working against, so I say that. And then tell it, check out all the CPP files and all the CU files. And guess what? It does just fine. So that got all the files checked. Now let's turn on some more checking. So basically you just say enable all. And you'll notice it comes up CUDA-worker.cu, line 19, style, the function Pythagorean kernel is never used, unused function. So this is one of the things you get. If folks remember, this is actually a false positive. If folks remember from the CUDA code, the Pythagorean kernel is called with non-standard C++. It basically, you specify the kernel dimensions when you launch it, how many threads, how many blocks, all that type of stuff. So this is a false positive, but it's reasonable, right? What you do is you basically say inline, and there's several ways to do this. Say inline suppress on the command line, and then you put CPP check suppress unused function right above the kernel call. And you notice that __ global __, that is CUDA as well, and it's being properly ignored. But all you have to do is say, hey, I'm going to use inline suppression, and then specify an override or a disable on the line of code that's offending, and it works just fine. I left the CPP check cannot find all the include files. There again, it's missing all the standard CUDA stuff that, CUDA include files. Yeah.
What's the granularity on your suppressions of messages? I mean, can you target it down to a particular statement, or is it just anything it sees in the directory? Or
no, so you can do, so it depends on exactly how you specify it. Generally, the way I've done it, and we can go look at this in a little more detail at the end. What you generally do is you suppress by line. So you can do, just turn off individual lines for individual checks.
how?
Oh, just like this. So it's, you put a comment, and then the CPP check suppress is actually a keyword that the CPP check picks up, and then say unused function. So that line turns off the unused function warning for that line of code. So it's line by line. It might make more sense in a minute if I pull it up in the editor. Okay. So you can also do it by file. You can do it by directory. There's several different ways to do this. I didn't dive into it because I generally don't do things quite that fancy. There's a JSON, I believe it's JSON file that you can specify as a configuration file for this thing that's quite flexible in how you tell it, check this, don't check that, turn this on, turn this off. And we'll go look at this. We're running nice and ahead here, so I can pull this up in the editor and we can look at things directly. There is an option to use the Clang parser. You just specify the path. This is experimental. I actually didn't try this because it breaks my use case of being able to check CUDA code. So that's the nice thing about this particular one. But if you want to use standard C++, and you want it to be, some standard that maybe they haven't caught up with yet, like C++ 26, maybe, and Clang has it, you can switch in a different parser. I've used the Clang analyzer in the past. It's also awesome. General recommendations. So we'll go, this is kind of wrapping this up. We'll go look at some actual code and do some running, and we can play around if folks want to. No single tool is going to cover everything. Use multiple tools when you can. So it's also pretty common when you're running a system or when you're running a development process where things need to be portable, you build with multiple compilers and you run multiple static analyzers. Everyone has its own strength and weakness. I've also seen where they do build matrices that include multiple versions of GCC, for instance. And just, if you're trying to be portable, that's kind of what you do. The more you add, the more stuff you catch. The more you add, the more stuff you catch, the more false positives and things you really don't care about are going to show up as well. So it's a trade-off, right? What do you need? What do you want? Static analysis can be time consuming. So what I tend to do is I don't run static analysis for my debug builds, right? So if I'm just working and trying to get something to work, right? Working along, trying to get things, just basically working. I tend not to do static analysis on every build, right? It is way too time consuming for that. When I get something working, then I'll do a static analysis run, okay? Always before I check in, I do a static analysis run. And if I get the luxury of having a CI system, I gate the check-in based on a pass of the static analysis tools as well. So I typically do this by if I'm using make or CMake, I have a make check, right? So you know how you say make clean, make debug, make release, however you'll do it. I just put another one that says make check. Make check runs my linters, my code, or my style analyzer, my unit tests, any of that additional tooling that I want to run to make sure everything's really, really good or as good as it could be before I submit it for code review or whatever the process is down the line. If you happen to be running a team, this is really the way to do it. Getting some teams to do code reviews and unit tests and analysis is painful. So integrate it into your CI builds, and then it just becomes the team's process, right? Generally, life gets better. You also should flag any disable check type statements. Most developers won't overtly try to bypass the system, but I wouldn't say it hasn't happened. So any of the disable check, whatever your tool happens to use to disable check, it's usually good to have a rule or two that says, hey, somebody needs to double check and approve this disable. You do need disables, as I was showing. They do need to be there, but you don't want them turning off all your static analysis checks, right? Place configuration files used to control the static analysis under version control, and that's how you control that. Just bring in the, either the build scripts or, as we'll look, the config files. If you're in a regulated environment, for instance, aerospace or automotive or medical, you really want to save your analysis logs. One of the reasons you run static analysis tools is certain environments require your code to be certified or qualified. And these analysis logs are one of the tools by which the reviewer can come in and say, hey, you did the right thing and you're up to snuff. Okay, any questions? So I know there was one. Let me go see if I can pull up the code here real quick. And let's look at let's see. Base installs. No. Ignore that, folks. That is my provisioning repository. If you do Linux stuff, this is total side note, not related to this talk at all, but since it's there, this is how I set up a clean Linux build. It's just a script that you install Linux and run this script, and it installs all the other junk you want. And I keep that under version control. It's a really helpful little tool. All right, let's see, close workspace. File. folder. Yes, I trust this. I'm the author. I trust myself occasionally. Not always. That's why I use tools like this. I don't trust myself. Okay, let's see, where was that? That was in. It was in CUDA Worker. Yep, right here. Okay, so here's, can folks see that okay? Hope so, because I don't know the increased font size on this one super well. Okay, so basically this is just your straight C++ file. The stuff that's tagged underscore underscore device underscore underscore host, those are tags in CUDA that tell the compile system and the build system to build this program both for the GPU and the CPU is what's being said there. So build it for the device, which is the GPU, build it for the host. Global tells it to build it for the host and dispatch, wait a minute. No, it's callable from the host and runs on the GPU. That's what that global means. So anyway, to give a little context on this, let's go down. Okay. Let's look at this line for a second. This will put this in a little better context of what's happening. Okay, so that highlighted statement in CUDA, so you notice the function is called GPU compute. This function dispatches the work onto the GPU. Furthermore, it dispatches the work into a bunch of threads. So without getting too much into the CUDA stuff, see my other talk on that. Yes.
Oh, I'm just listening in.
Oh, okay.
Rust.
No problem.
Rick, yeah, thanks.
Hey, we stole somebody from the Rust talk. I'll take it. No, no, so the essentially what happens in CUDA is your kernel runs massively parallel. So one thread is started up on each CUDA core. The name of the kernel in this case is Pythagorean kernel. And you'll see the triple less thans and the triple greater thans. Inside that's num blocks, num threads. And what you're doing there is you're specifying the geometry of the threads to be launched, right? This is totally non-standard C++, right? This is, you know, this code actually gets compiled by the NVCC compiler, not GCC or Clang or whatever else you happen to be using. So the NCC or the NVCC compiler will pull this out and then pass the remaining stuff down to whatever native compiler you've got going. And then, you know, after that, you've got device A data. Those are just all parameters, right? Just your normal formal parameter or actual parameters, excuse me. Okay. The static analysis tool does not recognize that as a function call, right? I wouldn't expect it to. It looks like nothing like a function call. So if you go up to the top,
There you go, but thank you.
yep. If you go up here where that function is actually defined, you'll see right above it, there's a comment, CPP check suppress unused function, right? And then it's the function call. All we're doing there is telling CPP check to say, hey, this is a false positive, turn it off. So that's actually suppressing that that unused function by you know, just the inline suppression mechanism. You also can suppress it in the configuration file by saying CUDA worker.cu line 20 suppress unused function. You'd specify that either in just a text file or there's a JSON file, if I remember correctly, that you can put that data in. You can also disable by function. You can disable by file. I think we can go look at it if folks want to. I think you have to get into the JSON format to specify that flexibility. And then you just say on the command line, CPP check, my exclusion file is this. If folks want to see this run real quick. So in this case, check.sh is what I don't have a full build system for this thing on this particular version. So I just stuck it in a batch file. So there's essentially what I'm doing. CPP check, enable all language, inline suppression. And that ran pretty quick. I mean, this is a pretty small file. Or excuse me, it's a pretty small project. Okay, other questions?
Any of these tools support incremental analysis?
The Clang analyzer might. If any of them are going to, it's that one. Now keep in mind, if you're using this like a make system or something, you can always have your make dependencies, check only what's changed too.
Yeah, I suppose that's true.
So you could do it that way. That will not necessarily catch everything, right? Because some of the analysis goes between compilation units. So things may vary. Yep.
You're in here, you give an example where you're suppressing one particular message.
Correct.
On one particular function.
Correct.
Are all of the suppressions such that you could easily find them? What I'm thinking of,
yeah,
your team is working, they have a code base, they do a bunch of suppressions. Is there something where you could run like a grep, run over this and just pull out and see where all of the suppressions were, and then like do a diff of that against what it was, what's been approved, and then that therefore you can flag all the new ones that can then get reviewed, updated.
If you're going to do that, then that's what you'll want to key on right there. And maybe not even that much. Just CPP checks -suppress, right? That's the keyword.
Because you could just do a grep on that, and you would find every instance in your code base where a suppression has been.
Yep. That's the way you would do it for inline. You can also put all your suppressions into a single file, right? And then reference that file on the command line. So if you go to check.h, you see where I say inline suppression?
Mm-hmm.
That tells CPP check to basically activate that keyword, right? So that tells it I'm doing my suppressions in line. There's another command line that says all of my suppressions are in a text file. And then you're going to reference it by file and line number.
How robust is that? If you edit the code and you insert a few lines, and now your line numbers are
exactly. That's the problem with that one.
Okay, and then how targeted are these suppressions?
They're pretty targeted. So let's just turn this.
There's some like you turn it on, but it applies to the whole class. And if it's a big class, you've disabled too much.
Yeah.
Versus being able to target like a very particular type at one very particular point in your code.
Yep. Let's just turn this one off real quick. And let me just run this again. I'll show you what this looks like. Okay. So basically right here it's saying the function Pythagorean kernel is never used, unused function. So if I was going to put this into a text file or the JSON file, that's the information I'd need right there, right? I'm going to say CUDA-worker.cu line 20, suppress unused function, right? This up a little bit so it's all in one line. And again, if I'm going to put it in line, then I'm just going to use that one. Let me go back and do this. Let's go, tell you what, probably the easy way to do that is let's go take a look at I didn't play too much with the the various config files. Just simply because that's not the style I was going to use for this particular one. Let me show you kind of what that looks like. Come here. Oh, sorry, it's not a JSON file, it's an XML file. Okay. So basically this one, there's a whole bunch of different ways to do this. So suppress spec, suppress warnings that match the spec. This is a spec file. Error ID, file name, line, right? So you can do them that way. You can do a suppression list. You can do an XML file, or you can do this template thing. So I haven't dug into a ton of this, but this looks pretty darn flexible to me.
The suppression list, what's the granularity of what you're specifying there?
I believe lines. Oh, wait a minute, suppression list file. No, the suppression, so for that particular one, it's a file.
Okay, you're just not going to generate any warnings for that particular file?
I think that's what they're saying there, yeah. Oh no, suppression list is suppression list is a file, and then what you're going to say is you're going to put it into this form, error ID, file name, line, and the file name and line are optional, and there's a wild card, so you can build wild cards. So I haven't played with this a ton, but this looks pretty pretty in depth. Looks like you can also show a call stack. You may be able to do something with that. Oh, that's for formatting error messages. Yeah, so it's basically these guys here. Suppress spec, suppress list, suppress XML file. And let's see, some of this was listed in the manual. So if you go to the manual, there's a pretty good section on doing this. I believe you can also build plugins to do something like this as well with this one. This one has a plugin, go up here. See that. Add-on. So you can get into what it's doing internally and build stuff with Python. But I have not looked at that at all. But it's, and let me put it this way. This one's open source. So if you really wanted to get in there, you could go into the tool itself. Okay, other thoughts, questions?
Yeah. So do any of these support auto completion or auto correct, whatever? I mean, if you have a memory leak, does it say you should add a whatever, delete?
Not that I've seen. I haven't seen that in any of these. I'm hesitating because that's really common on the Rust linter. Clippy does that. Matter of fact, Clippy integrates well enough. A lot of the common errors that you come up with, if you're in Visual Studio, Visual Studio Code, I haven't tried Visual Studio, it'll put up a quick fix button. It's like, here's your error, here's the suggested fix. You hit quick fix and it changes your code for you. I have not seen anything like that in the C++ world. Even as far as just the suggestion.
How accurate is
For the Rust side?
making the appropriate fix?
So making the appropriate fix in Rust, making the appropriate fix from a Clippy suggestion is probably about 80% accurate. Rust has another tool. So Rust has the concept of additions. So it's kind of like if you go from C++17 to C++20, right? Rust does it a little differently. There's also a auto fix in that. So if, when a new release comes out, they'll update Clippy to, just do more changes. I've actually found that, and I'm sure it's not, just my experience, to be basically 100% accurate. It creeped the living heck out of me the first couple of times I tried that, because with Rust, they release every 6 weeks, right? And with that, they also release Clippy with more checks in it. And so when you're working on a project like that and you're enforcing code style and static analysis, it's very common to every 6 weeks when you update your compiler, have 3 or 4 things you need to fix, right? And they're usually pretty darn simple. I've gotten comfortable enough with that to say, and keep in mind, I've got unit tests in place, right? I would not do this if I didn't have unit tests because there'd be no way to validate. But with good unit test coverage, I'm comfortable enough telling Clippy, just go ahead and fix everything. And then I review it and double check. And then I run my unit tests. And then I hit submit. And to date, that has not burned me. I have heard a couple other people that every once in a while it misses something. But it's pretty darn good. I have not seen anything like that in the C++ world, though.
Yes, I'm familiar with the C# world, and that's a pretty common thing.
Is it common in C#?
Oh, yeah, and it's very accurate.
Yeah.
So the other question I had is, suppose I want to have my own rule set. Custom static analysis.
Yep. That's this.
How?
That's these Python add-ons.
Right, that's the mechanism here.
Yep.
You have not done
I have not played with that, no. Let's put it this way. I'm happy enough when I get to run static analysis just on any default setting I can get my hands on. I have not had the luxury of working in an environment where it's like, oh, let's go make our own analysis or our own, lints.
It's pretty helpful if you have, especially with new people. It's like
it's incredibly helpful.
Yeah.
No, it's incredibly helpful. Teams where I get, when I'm in the lead role and I get to actually run, set the policy and so forth. Not always, but it happens. I generally do all of my basically the coding guidelines I express as style analyzers and linting tools. And I've used the Clang tool set. You just pick a style and it just says it. And that works really, really well because you don't have the debates. It's like, hey, we're just going to go with XYZ standard style guide, right? And it's one of them I pick, whichever one we decide, we pick out of the Clang tool set. And everybody says, okay. And then everybody just, agrees with it, right? Sometimes there's some debate, but, basically it's like, okay, this is good enough. And, you don't have the, well, do I put the curly brace on the same line or the next line or, the else, all that just goes.
I'm thinking more about
pick one.
High performance environments where the code is stylistically is perfect. It's great language syntax.
Oh, but you want.
But yeah, this is like not the way to maximize the performance. Don't do this.
Yeah. So at that point, I think, having your own lints in there would be absolutely the way to go. Because, you can pick like.
In terms of writing your own lints?
Yeah. Like, I don't know. I do.
More of an analyzer than a lint.
It's more of an analyzer, but like, let's just say you don't want to use memcopy, right? Or, I'm just making that up. I'm not sure whether that's one of yours or not. You can just say, anytime I see memcopy, kick it out, right? Use my fast memcopy instead, or, whatever it's.
Well, a big example.
That's.
And this is a C# world, but it's like, don't use link. LINQ. These high performance applications, even though it's very nice and it's kind of standard, it's like this will not perform very well in some situations.
Right.
In fact, it'll perform terribly.
Yeah, you could definitely. I know with Clang for sure, because I've seen other people doing. That's how Clang is built. This one looks like you could do it with this tool. I'm not sure about any of the others.
Do you really want to write your own rules, or you load in a bunch of rule sets and say, I want to apply this rule set, and not that rule set kind of thing. Because I think a lot of the analyzing tools
You can do
have,
that.
have 1,000 rules, and you can go through and click
Yes.
as to which ones you want and which ones you can turn off. And
Right.
you would want to just,
As far as I know, there were no built-in rules such as that, but, or such as what I was trying to achieve.
Yeah.
Otherwise, yes.
No, that's a very domain specific
Yeah.
type of thing, but, and that's gonna come up all the time, right? If you're in high reliability, computing areas, right? Malloc, new, free, any dynamic memory allocation is generally prohibited. So I see the word malloc, it's not going in, right?
Probably built-in rules to that effect.
They're not in this, they're not in this one. The MISRA C stuff would probably have something like that. And then, of course, just as a further disclaimer, if you're going to do that, you also have to throw out the static library or the standard library. Because the standard library typically has mallocs and news and frees in it. And in a lot of high reliability environments, you can't use that either. So in those environments, it's really common to see they throw out the standard library, and this is embedded. These are typically embedded projects, so it's easier to do. They throw out the standard library and build their own specific functions for the handful of things they're going to allow people to use. So that's really common as well.
So do you have any advice or thoughts on the interaction or compatibility or anything having to do with dynamic analysis with these tools? Does it make no difference whatsoever, I assume, but.
Yeah, as far as I can tell, I've not used the dynamic analysis tools nearly as much. And I'm thinking, I can think of the name of one of the. That's the name of the analysis tool. I'm drawing a blank. The one that checks for memory overruns and things like that. Memory overruns. Huh?
Valgrind?
Valgrind,
Yeah.
thank you. Yeah, I have not used that one nearly as much. In my mind, these are complementary. Ideally should run both. But yeah, I haven't done as much with Valgrind and its other friends. There's several of them.
a big part is being able to target your suppressions very, very narrowly,
Yes,
because it's good to write lots of rules that cover lots of things, and inevitably you will have false positives.
right.
And then if you don't have a suppression, you end up with this, there's a list of 1,000 false positives out there. You write your code, there's 1,001. You're not going to go look for
Right.
the new one, and maybe that one wasn't a false positive, and hence you let a problem through you should have caught.
Right. That's actually something I should have put in the recommendations or the summary notes. When you build, no warnings, no errors are allowed. Right.
You keep that up for the entire history of the project and don't allow something
Exactly.
to check in 100 of them, and then everyone else have to keep dealing, trying to find their one in the midst of 100 others. And then the other thing is, your suppression isn't narrowly targeted. You turn off message X in this function.
It goes right.
You're not seeing the false positive in the one spot you intended to turn it off, but eventually someone may introduce a new true positive someplace else in your code that you will no longer spot. Yeah, correct. Yeah, and I do that. Basically, I turn on all warnings as errors, right? So no warnings. A warning always gets flagged as an error. The CI system has to compile without error. And I turn on all the warnings and errors as well. And then if I need to turn a couple, every once in a while, it depends on what we're doing. There may be a general class of error that you want to turn off. That's fine. But then it's, every specific instance, you have to go turn off just the specific one that's creating the problem. Well, and I think another thing is, all right, you introduce suppressions, and then you want to be able to sort of, that's something to check at code review time.
Exactly.
Did you suppress this? And therefore, if you create a new one, you want to be able to incrementally see, just pay attention to the new ones and not have to
Right.
also review all the old ones. Because if you have to do that every time, then pretty soon people don't pay attention.
Right. And usually your diff tools, at least when I'm doing code reviews, I'm in their diff tool. So, it looks like just a standard code change line with and that's why I kind of go with the inlines, because it just looks like code, right? Now I just review it as part of the code base.
So I didn't notice, but as a segue, are some of these tools providing like error codes where you can look it up and get a much fuller description of, okay.
Yeah.
And then you can suppress based on that particular code as well?
Exactly. Yeah, and you can see that if you go, unused, this one's pretty obvious, right? Unused function is the error code.
Oh, okay.
Right.
That was just a description.
No,
It's actually.
that actually is the
Okay.
error code. And if we go back to the, see it. Yeah. If we look at this line right here, that's how the error comes out. And you'll see it's right there in the square brackets, unused function.
It's very
So-
descriptive, right?
It's-
It's some random.
Yeah, it's, until you get recognized, hey, here's the pattern the thing's doing, you're gonna read over it. But once you recognize, hey, it's the thing in square brackets is the magic chant that I need, it's right there. Okay.
So I'm kind of amazed that people actually don't use these static analysts.
Yeah. That was actually one of the reasons for the talk that, I had gotten into, basic on just projects I'd done and so forth, where we absolutely had to have it. A proprietary, paid version was used, right? And where I could, I managed to wiggle CPP, the Clang tools, I'd use those where I could, any place I could, because they're pretty easy to set up. But that was kind of the motivation for this talk, is it's like, hey, I've kind of done this. I've actually got a little time. Let's go do a survey of what's out there and, see if we can pick a different one and try it. And that's what this, primarily was.
I don't know whether you're willing to put anything out there regarding the proprietary ones, but yeah, I'd be interested in any thoughts if you are able to share them.
I'm trying to think. Let me pull up a browser real quick and see if I can find the name of the one we were using.
There's Parasoft, Perforce, I think has one.
No, the one I'm thinking of starts with a C, and it was
Like
Coverity.
Yeah,
That's it.
Yeah.
Yeah, that was the one we were using. And it was good. I mean, it was, another one that we did use, it was embedded related. It also had who makes this one? TI. I cannot remember the name of the tool. It's in the TI's tool chain. It not only has the static analysis, dynamic analysis, but the tool can do cycle counting as well. So if you're in this was an aerospace environment, right? It was a controller for aerospace. You've got a very tight loop time that you have to meet. And it could actually analyze your loop times and ensure that you're going to meet your metrics. And it does so on it's more than a cycle by cycle basis of the CPU. It actually goes down to that level. And it takes a boatload of time to configure this tool. But it can look at your peripheral IO times. It can look at memory caching and, speed ups or slowdowns for cache hits and misses. It can look at transfer times if you're in a multi-core system. All of that is in there and can be profiled. And that tool, I don't know how much it was, but it was really, really, really expensive. it made 25K look, like child's play. But just for reference, some of these aerospace tools and stuff, and I just throw this out because, folks might want to be sitting down for this. $100,000 per seat per year is not unrealistic for some of these tools. Per seat per year.
Sounds like a good business to be in.
And let me put it this way, that some of these tools are worth it. What is it? MathCAD? I think it was MathCAD. Had a tool add-on that was in that price range. And I sat in on there was basically a sales pitch for the thing. And in an hour, the guy, developed the base code for a autopilot for a helicopter to hover. You put in your flight dynamics, you put in, things like mass of your vehicle, stuff like that. And it spit out code that was 80-90% there. You had to go still tune it, right? And of course, keep in mind, this was a sales pitch and there was a lot of eye candy floating around on it, right? But, what would take somebody a year or two to develop that code base from scratch was done in an hour. And, you're going to spend another couple of months tuning it. That's easily worth $100,000 a seat per year. The other place you see that is chip design tools. I've not played in that space, but last I heard they were easy $100,000. The CAD tools that design integrated circuits, are in that same type of price range. You got the big bucks. Okay.
Mostly we've been working in the Windows world for the last number of years and gotten away from Linux, but are there any performance monitoring tools that you recommend?
I've been going to the Linux world, so all the stuff I've been, there's perfmon and stuff like that. In the Windows world, actually, I use Resource Monitor quite frequently, and it's fine. It's not fine grained. It's very coarse, but if you can look at your CPU loading, if I tend to do multi-threaded stuff, just looking at that and getting a good heartbeat off of it is actually will give you a fair amount of information. Trying to think, the Intel compiler suite has a lot of very fine-grained performance monitoring tools, and I've not used it, but I did a talk, it was 6 or 8 years ago now, in parallel with some Intel folks, and they were, talking about that suite. The other one is if you go into CUDA. So the only thing, and keep in mind, to run the CUDA tools, the only thing you need, you need some, GPU in your system, right? Doesn't have to be a fancy one. Just has to be, could be your main video card, right? A couple $100. And you've got what you need. The CUDA development tools. What do they call it? I can't think of the name of it off. I could switch to my I don't have them installed on this. But the CUDA tools have a very, very detailed performance monitoring. And they can actually tell you as processes switch threads, or threads get handed off to different CPUs, and you could look at lock convoys and thrashing across CPUs and cache issues going between CPUs on the main CPU, right? Not just on the GPU, but also on the main CPU. So in the Windows space, I'll just pop one of those up if I really need it. Yeah, it just happens to be the same tool I use for CUDA stuff, so. Okay, anything else? Okay. If folks don't have anything else, I think I'm going to go ahead and wrap this up because I need to be up at 4:45 tomorrow because we're going somewhere. And we have to catch a ferry. And if we don't catch said ferry, it's going to be bad. And if I wake up at 4:45 in the morning, it might be bad. I'm a morning person, but that's going to be pushing it a bit for me, so. Okay, whoops, let's see. All that. Make sure I put my check back. That's there. Okay. Folks online, did you guys have anything or? Yep, thank you. Yep. Thanks, Scott.
Yeah, thanks.
So just a quick note, folks who want to head over to the Red Robin, that's there. We will be still meeting next month in the reactor room. We will be a joint meeting with the Rust user group. And I'll get that information out shortly. And after that, we are looking for a home. So we will be online until we find a home. So we're not giving up, but we will be adjusting a little bit. Okay. Thanks, folks. See you next month.
It's like
Yeah.